Hey everybody, so we are going to be in your packet on page 95, and I have another little supplement page that I'm going to be showing you first that will hopefully kind of make sense what we're going to do here. So what we're going to start to do is we're going to start to solve rational equations, which means we're going to see a fraction. And I just want you to get an idea that as long as you are good with, fractions, that you will be able to do this. So the idea looking at this problem, this is a really simple version of a problem, is if you remember when you add or subtract fractions, you need a common denominator. So that's why you see 3/5 plus x fifths equals 7/5. You don't actually add the denominator, you just bring the denominator along. So what actually ends up happening is if you do have a common denominator all the way throughout the problem, then your focus of the problem is just going to be in the numerator. So 3 plus what number makes 7, and most of you can probably just realize at this point that that is 4. So 3/5 plus 4/5 makes 7/5. Now it's not always going to be the case that you have a common denominator. So in this problem, what I would want to do, just like we did with adding and subtracting fractions, because there is addition and subtraction here, is find that least common denominator. And our least common denominator here would be 10. So to get this one to be 10, I'd multiply the bottom and the top by 2. And then I'd do the same thing over here, multiply the bottom and the top by 2. So when I'm done, this fraction becomes 6/5. This one I never had to change. 6 tenths. X tenths. And then this one is 14 tenths. And so now, if the denominator is common all the way throughout, what I'm asking myself is 6 tenths plus how many tenths makes 14 tenths? Well, that x would be an 8. And so once those denominators are the same, we're going to use the phrase, you can let it go. You're going to channel your inner Frozen, and you can just focus on the numerator and solve for x. So by subtracting 6, we get 8. All right? So that is the basis of this whole thing, is we're going to try to find a common denominator throughout our fraction. And once that we have that common denominator, we can let it go. Very similar to what we did in our previous chapter, that if you had this as your problem, that if the bases were the same, you could ignore the bases and just focus on the exponents. So here what we'll do is ignore the denominators once they're the same and focus on the numerators. So that is the idea of this. So what I'm going to do is jump to page 95 now, and I've got some steps here. These are very similar to what you got on that purple cheat sheet. And I did a little writing here, but then I had to start over. So bringing my pencil back. All right, so this problem is just like what I showed you here. What I want is to have this fraction be the same denominator as these fractions. So right now, that fraction, this 4, is currently over a 1. So to make it a denominator of x, what I'll do is multiply the denominator by x, and whatever you do to the bottom, you do to the top. So my fraction becomes 3x, and here I get 4x over x equals 2 over x. And now that the denominator is the same, you can let the denominator go. You can just ignore it and have the numerator be your problem to solve. So from here, to solve for x, very basic math, I'm going to subtract the 3, which gives me a -1, and then I'll move the 4 by dividing by 4, so I get -1/4. All right? Now, one thing we're going to have to consider, because we're solving, is we will have domain restrictions. And we've already talked about this, because when we were making our graphs, one thing we talked about, since x is in the denominator, that your denominator can never be worth 0. So what we want to do is just make sure that our answer, if we put it back in here, well, is it going to make that denominator 0? If it does, then it's called an extraneous solution, and we wouldn't want it. And we heard that word in the last chapter, extraneous solutions. You might get an answer, but if you put it back in, it doesn't necessarily make that answer work. All right? So if I put -1/4 back in my problem, the main thing I'm worried about is, will it make the denominator 0? And it won't make this denominator or this denominator 0, so this is a good answer. All right, on the next one, again, what I'm going to do is find the least common denominator. So going back to this one, this is just over 1, right? And this has an x, this has an x squared, and this is a 1. So what I could do is make all of these become x squared. So what I'm going to do is, this one's good, so I can leave it alone. For this one, I can multiply the denominator by x and the numerator by x as well. Whatever you do to the bottom, you do to the top. Same thing here, except this one will have to be an x squared to get that common denominator. So my first fraction, as far as the denominator goes, is x, but my numerator is 3x. And the next fraction it's x squared down there. In my next one, the denominator is x squared, and my numerator is x squared times 1, which is x squared. And now that that denominator is the same, what I can do is ignore the denominator. I can let it go. And then the numerator becomes our focus for our answer. So the difference between this numerator and this numerator is this numerator had one type of x. This numerator has two types of x. So I'll have to factor, which means I need to get it in standard form. So first I want it set equal to 0, and I need to bring that 4 over. And I'll do that through subtraction. And then the other part about standard form is the x squared goes first, then the x term, and then the minus 4 will go last. And now that it's in standard form, I can factor. So I need factors of -4 that get me to 3, and I will choose 1 and 4 with the 1 being negative. I'm going to make my parentheses really fast, drop in those x's, and then I'll double check, is x and x enough? Does x times x make x squared? And it does, so we're good. And then if you like to draw the face, the top of the head and the smile to make these side numbers, x times what makes -1x, and that's a -1, and x times what makes +4x, that's a +4. And now when we're done, if you remember back in first semester, you just set your parentheses equal to 0, each of them, to see what will make them be worth 0. So one answer is -4 and the other answer is 1. And now what I want to do is check, are these extraneous solutions? So if I put -4 in my original problem, do I get 0 in the denominator? I don't. And if I put 1 back in here, do I get 0 in the denominator? And you don't. So we actually have two answers, and I'm just going to rewrite them over here, -4 and 1. So let's take a look at this one. So again, what we're going to have to do is get a common denominator, just like we did in adding and subtracting. And this time it might be a little tougher to see the denominator. So going back to those rules that we saw before, and on your purple cheat sheet it'll be really similar. What we're going to do is we're going to add the opposite between the fractions if it's needed, and then we're going to factor our denominators completely. So I don't have to add the opposite here between the fractions, we're good. And x minus 4 can't be factored, and x plus 1 cannot be factored, but this can be factored. So I'm going to factor this, and as it turns out, it's very similar to this one. I need factors of -4 that make -3, so I'll still choose 1 and 4, but this time I'll make the 4 negative. And when I make my parentheses and drop in those x's, x times x is good, it's x squared. And then to get the side numbers, I can do x times a +1 to get 1x, and I can do x times a -4 to get the -4x. So this one's gone, and it's been replaced by its equivalent version of factored form. And here maybe you can see the least common denominator, especially after the last chapter. But if you can't, you can make that table that I talked about. I think for sake of room, so I really don't know how much room I'm going to need, I'll put it on a different piece of paper. So, we called it that least common denominator table. So my first fraction, I'll put in x minus 4. My second fraction, I'll put in x plus 1. And then my third fraction, I'll put the x minus 4 there and the x plus 1 there. And then if you drop everything down, you find your least common denominator. So all the fractions need both of these things. So the last fraction has both of them, but the first fraction only has the x minus 4, so it will need the x plus 1 on the bottom, and whatever you do to the bottom, you do to the top. And this one has the x plus 1, but it's missing the x minus 4, so whatever you do to the bottom, you do to the top. And now that my denominator is the same, what I'm going to do is let the denominator go and just bring the numerator down, and that will be the focus of my problem. So this will be 2, so this is all the numerator, 2 times x plus 1. This is the plus in between the fractions, and then 1 times x minus 4, and then equals the 10. And now to start solving, I'll just distribute. So I get 2x plus 2 and 1x minus 4, and that equals 10. I will combine my like terms to make 3x, and combine these like terms to make negative 2. And now when I'm done, I just have one type of x, just like I did up here. I can just get that x alone, so I'm going to add the 2 over, and then I'm going to divide by 3, and I get 4 as my answer. And so now I want to check, is 4 a good answer, or is an extraneous solution? So if I go back to the original problem, and I can look at it, ignoring these, I can look at this. This is still the original problem. Does putting 4 back in here make any of my denominators 0? And it does. It does here. So that means even though I got this as a solution, it's called an extraneous solution. So it works for solving, but it doesn't work when I plug my answer back in, because I would get 2 divided by 0 here. So, all right, the next one. Let's assume you do not see the least common denominator. So again, following these directions, I want to add the opposite between the fractions if needed. I don't need to do that. I want to factor the denominator completely. You can't factor x or x plus 1. And then we want to find the least common denominator. So if you need to make that table, fraction 1 gets an x, fraction 2 gets x plus 1, and fraction 3, well, it doesn't, well, I guess if it had a denominator, it's 1, but it doesn't have a denominator. Sorry, you couldn't see that. So what I'll do is drop everything down, and now all the fractions need an x and an x plus 1. So I'm going to go to each fraction and make sure it has everything I need. So this fraction, and there's not a lot of room here, so let me rewrite this. This fraction has the x, but it doesn't have the x plus 1. So I'll put it on the bottom, and whatever I do to the bottom, I'll do to the top. This has the x plus 1, but it doesn't have the x, so I'll put it on the bottom, and whatever I put on the bottom, I do to the top. And this one will need both of them, so it will need the x and the x plus 1. And again, whatever you do to the bottom, you do to the top. And now that your denominators are all the same, they're all x and x plus 1, you can let the denominator go, you can ignore it, and then the numerator becomes your problem. So this numerator will have 3 with x plus 1. There's the plus sign. This numerator will be 4 times x, and this one will be 2x with the x plus 1. So what I'm going to do right now is start my solving. I'm going to distribute. So I get 3x plus 3. There's the 4x. And then I'll distribute my 2x through, so I get 2x squared plus 2x. And now comparing this to over here, this had one type of x, this has more than one type of x. So we're going to have to get it into standard form. Just like before, it needs to equal 0. We want the highest exponent, then the next, till we get to the constant. So before I do that, let's just clean up this side. This side can become 7x plus 3. And now what I'll do is bring the 7x over to join the 2x. So it makes it negative 5x, and I'll bring the 3 over through subtracting. And now it equals 0, and it's in standard form, so I'm going to make my x. There's not a GCF, so I need factors of negative 6 that get me to negative 5, and you got to be really careful with this one because it's going to be 1 and 6, with the 6 being negative, not 2 and 3. So I'll make my parentheses, drop in my x's, and then I will double check, is x times x enough? Nope, I need 2x squared. So I'm going to have to put a 2 with one of these, and I'm going to draw my loops and to get these numbers, and x can make either of these, so x isn't picky, but 2 can only make this. So 2 times a negative 3 makes this. That means an x times 1 can make that. And now you can set your factors equal to 0. And you can solve. So here I would add 3, so one solution is 3. And here I would subtract 1, and then I would divide by 2. So my other answer is -1/2. And now I just want to see, are these extraneous solutions? If I go back to my original problem, 3 is fine and 3 is fine here. They don't make the denominator 0, and -1/2. -1/2 is fine here, and -1/2 is fine here because it doesn't make the denominator 0. So both of these solutions get to stick around. All right, let's see. Let's just try one more. And let's have it be the one at the bottom, which is a little bit more of a challenge. So I've just jumped to page 96. And so again, what I need to do is, there's no subtraction in here, so we're good there. And I'll need to find that least common denominator, so I will have to factor these denominators completely. So starting with this one, I see a GCF, and I can take an x out and have x plus 4. So I don't need this version. This one is a difference of squares, so this one can turn into x plus 4 and x minus 4. And this one's the same as this one, so it can become x and x plus 4. Now there are other ways to solve this problem, and I'm just sticking with the same method. So if some of you start to notice some other ways to do this, or you're not sure, just check with me. So now if you don't see the least common denominator, again, here goes my least common denominator table. Fraction 1 has an x and an x plus 4. The second fraction has an x plus 4 and an x minus 4. And then the third fraction has an x and an x plus 4. So now, hopefully by now, you can see the least common denominator. Well, everything will need an x plus 4, and an x minus 4. And I'm going to wrap these in parentheses. So when I look at the first one, it's missing the x minus 4. So let's find a different color here. So I'll put an x minus 4 on the bottom, and whatever I do to the bottom, I do to the top. This one's missing the x, so whatever I put on the bottom, I put on the top. And this one's missing the x minus 4, so I'll put it on the bottom and the top. And now that my denominators are the same all the way, I can ignore the denominators, I can let them go, and my numerator will be my problem. So the first fraction has a numerator of 3 times x minus 4. The second fraction has x times x, which I'm just going to go ahead and write as x squared. And then this one has a 2 times an x minus 4. So now to start solving for x, get rid of those parentheses, I'm going to distribute. So I get 3x minus 12 plus x squared. Here I get 2x minus 8. And so now I have more than one type of x. I'll need to get it into standard form. So let's bring these over here. It's always best if the leading term is positive. So we want to keep this x squared positive. If I move it over here, I have to move it through subtraction. And we don't like, it's not easy to factor when your leading term is negative. So x squared will go first. I'll subtract this 2x to join the 3x, which gives me a 1x. And then I'll add 8 to the negative 12, right, to get negative 4. And now I'm going to try to factor. So I would be looking for factors of negative 4 that get me to 1. And as it turns out, this is not factorable. So the reason why I'm going to bring this problem is just to remind you that if you can't factor, that you will do the quadratic formula. So we'll need to recognize that a is 1, b is 1, and c is negative 4, and then go to our song. So x equals opposite of b plus or minus a square root b squared, so 1 squared is 1, minus 4 times a times c, and then all of that's over 2a, so 2 times 1 is 2. And then we'll focus on the radical. And in the radical, you have subtraction and multiplication. So the first thing I'm going to do is get rid of the subtraction and add the opposite. And this becomes, if I do my multiplication, 16, and then 1 plus 16, that makes this the square root of 17. So I have negative 1 plus or minus the square root of 17 over 2. The next thing I would want to do is see is 17 perfect, and if it's not, maybe it has factors that are perfect, which it doesn't. So this is a fine answer. If you really want to know the decimals, then what you could do is you could take -1 plus the square root of 17, hit enter, so that's your numerator, and then divide it by 2. So there's one x value, about 1.56. And then I could do -1 minus the square root of 17, hit enter, and there's my numerator, and divide that by 2. And my other answer would be a -2.56. You are just fine leaving it like this. So I wanted to review this because if you are planning on doing our very first capstone, that tends to have a quadratic formula in there because you can't factor. So this was a good review. And that's it. Those are your notes for adding and subtracting.